Okay, welcome to Math 1324. This is Chapter 10, Section 2, Example 8. In this example, we have let C of x be the cost to produce x batches of widgets and R of x be the revenue in thousands of dollars. Complete parts A through D below. Okay, so R of x here is defined as negative x squared plus 10x. C of x is 2x plus 12. We want to graph both functions. The vertex of R of x is at blah, and the y-intercept of C of x is at blah. B says find the minimum break-even quantity, C says find the maximum revenue, and D says find the maximum profit. And this is bringing in information from Chapter 1 that you may have forgotten. Okay, so first of all, we're going to treat each of these separately. First on A, we're dealing with graphing. I'll go ahead and let you just graph it on the calculator. I'll show the calculator at the end. But for A, we also want to find the vertex of R of x. Notice that R of x is a quadratic while C of x is a linear function. Now R of x being quadratic means that it has a maximum or a minimum. Now that vertex is always the maximum or minimum, and to find the vertex, we use this formula. So for R of x, A is -1, B is 10, and notice that there is no constant at the end. That means that C is 0. Its y-intercept would be 0. That's not what we're asked for, though. So plugging that in, that gives me -10 over 2 times -1. -10 over -2 makes that +5. To find the y value, plug that +5 in, makes that negative parentheses 5 close parentheses squared plus 10 parentheses 5 close parentheses. So 5 squared is 25, making it a -25. 5 times 10 is 50. -25 plus 50 is 25. So that means that the vertex for R of x is the coordinate 5, 25. Good, and it's opening down, so that's actually the maximum value. As for the y-intercept of C of x, well, since C of x is y equals 2x plus 12, the y-intercept is, well, that's the slope-intercept form, that's going to tell me y equals 12. Now that I'm telling you what my math lab wants. Personally, I would prefer 0, 12, but I'm not really going to be grading it, so do what my math lab wants. Alrighty, so y equals 12. Awesome. That's A. B, find the minimum break-even quantity. The definition of break-even is where the revenue is equal to the cost. In other words, the profit is equal to 0, because profit is defined as revenue minus cost. So let's just use revenue equals cost for now. So for letter B, we want to say the revenue equals cost, which means -x squared plus 10x should equal the cost of 2x plus 12. And notice that for this one, I can do whatever you want. You can move the x squared over here, move the x's and stuff over. It doesn't really matter. Just get everything on one side. I'm going to add x squared and subtract 10x. So that means a 0 on the left, and on the right, I will have x squared, and then 2x minus 10x is negative 8x plus 12. And at this point, I could either use the calculator or factor, and the factorization is actually not that hard. And then set each factor equal to 0. So that would tell me that x equals 2 and x equals 6. But notice that it wants the minimum break-even quantity, which means I need the smallest of these two, and the smallest of these two is 2. So the break-even quantity is at x equals 2. And remember, x is the number of batches of widgets. You could have also used the program quad on the calculator. So if I type in program quad and then 1, -8, and 12, it gives me 2 and 6. That's all it is. Now, notice that I didn't have to add the x squared and subtract the 10x. I could have subtracted 2x and subtracted 12, and I would have been left with this. -x squared plus 8x minus 12 equals 0. And then you can just go with that one as well. So if you type that into the calculator, where a is -1, b is 8, and c is -12, it again gives you 6 and 2. It just flips those around. So just make sure that your smallest between the two is 2, so x equals 2. Same answers. Letter C, find the maximum revenue. Now again, revenue is this function. So -x squared plus 10x. But also notice that when you graph this, it's going to look something like this. The maximum is just going to be the vertex. And the vertex was 525. So as a result, we need 25 for the y value. So x equals 5 and y equals 25. Or in other words, the revenue is 25. Now 25 what? R of x is the revenue in thousands. So the maximum revenue is $25,000. Awesome. It's the great thing about that. We've actually already answered that part of the question. However, letter D is a little bit different. We have not answered that question. We want to find the maximum profit. And remember, profit, by definition, is revenue minus the cost. Our revenue in this function, or excuse me, this question is -x squared plus 10x, and then subtract off the cost, which was 2x plus 12. Make sure we distribute that negative. Will give us -x squared plus 10x minus 2x minus 12. And 10x minus 2x, so it gives us -x squared plus 8x minus 12. Good. Now, notice one thing. This is our profit function, but we've actually already seen that before. We saw that right here. So the profit function, set it equal to 0 and solve, that gives you break-even points. Okay, so let's look at this. Where is this going to reach its maximum? In 1325, we'll just find the derivative and go from there. But here, since it's a quadratic and the leading coefficient is negative here, that means that it's going to look something like this, having a maximum point there. And that maximum is the vertex. So really what we want to do is find the vertex. The x-coordinate is where it occurs, the y-coordinate is what it is. So x is where, the y is what. So to find the x-coordinate, we use h equals -b over 2a. -b is -8 over 2 times -1. So -8 over 2 times -1 is -8 over -2, which is 4. And the k value, if you plug that in, that gives you negative 4 squared plus 8 times 4 minus 12. And then simplify. Negative 16 plus 32 minus 12. 32 minus 12 is 20. 20 minus 16 is 4. So the question asked for us to find the maximum profit. So that means that the maximum profit is, and it comes from that right there, 4. But remember, this is all in thousands of dollars, so put $1,000. Good deal. And that's pretty much it. I do want to look at one thing, though. Notice that the maximum revenue is 5, or occurs at x equals 5. The maximum profit occurs, though, at x equals 4. That's very important. The maximum profit when you have a quadratic revenue and a linear cost function like this, the maximum profit will always occur before the maximum revenue. It's a little bit weird, but it's true. It has a lot to do with marginal revenues and marginal costs. Okay. We'll talk more about that in 1325, though. Alrighty. From here, I do want to go ahead and try and show that entire thing. Awesome. And then I will show you on the calculator what this looks like. Have fun. Welcome to the calculator. So a couple of things we wanted to do. First was to graph these two. So if I'm to graph this, I have negative x squared plus 10x for the revenue, and 2x plus 12. And then zoom 6 will graph it. It's kind of hard to see though, so let's change our window. Minimum x of 0, maximum x of 10 works. Minimum y of 0, maximum y, let's go 30. There you go. Now notice that linear cost function, quadratic revenue. And in here, the area between these two, where the revenue is higher than your cost, is the place where you're making a positive profit. And you can see that. In fact, you can see that the maximum profit will occur where the highest revenue and the difference between the revenue and cost is the highest. So here, approximately somewhere in here, is where the maximum profit will occur. Notice at the vertex here, the linear cost function is actually closer to the vertex than you are here, which is the reason why the profit function will have a maximum profit before you reach your maximum revenue. Okay, so let's go ahead and graph the profit function, which was negative x squared plus 8x minus 12. You can see where first of all, the break-even points are right here at the 2 and the 6. But you can also see that the maximum occurs at x equals 4. Alrighty. There were a couple of times I used the quadratic formula. Well, actually, no, just once. So let's use the quadratic formula. Let's say 1 for A, negative 8 for B, and 12 for C. That was what I used. That gives me 2 and 6. Now if I flip that around, making that negative 1, program quadratic formula, making that negative 1 for A, B is positive 8, and C is negative 12. Notice it gives me the same values, just flipped around. That's all. I still choose the smallest of the two, and that's it. Alrighty. Well, that is the calculator for this particular question. Have fun.